CLO 2.2, determine trigonometric ratios for angles 0, 30, 45, 60, 90, and we will use that to solve problems. Okay, just as a summary, when we say the word right triangle, we're talking about any triangle that has a 90-degree angle in it. And it turns out that if we have just two pieces of information about that triangle, whether it be one of the angles and one of the sides or two of the sides, then we can use that information to find everything else we need. That's called solving the right triangle, finding every angle and every side. So again, all that we need is either two sides or one acute angle and another side. If we have either of those categories of information, then we can find everything else. Now this picture should be review from what we already learned in lesson 2.1, but if we were to draw our right triangle on the coordinate axes and put the angle theta in standard position, this angle theta, relative to this angle theta, we would call B the opposite side, and A the adjacent side, and C the hypotenuse. So if you remember this memory device, SOHCAHTOA, sine is the opposite over the hypotenuse, so it's B over the hypotenuse, C. Cosine is the adjacent over hypotenuse, which is A over C, and tan is the opposite over the adjacent, B over A. And just remember, cosecant is the inverse function, so it's just C over B. And secant is the inverse function of cosine, so it's just C over A. You just flip it from the cosine. And tan is the inverse, or 1 over, cotan is 1 over the tan function, so instead of B over A, we get A over B. So let's look at a question related to this. It says, refer to these circular points that are given to find the 6 trigonometric ratios for pi over 6. And if you're not comfortable with radians, you can always do the conversion and realize that when you multiply by 180 over pi, this is equivalent to a 30-degree angle. So really we're talking about a triangle right there, pi over 6. And you can see if we were to zoom in to this triangle, this is our 30-degree angle, that's pi over 6. Here's your right angle. It tells us that the x distance is square root of 3 over 2, and the y distance, the height, is 1/2. Again, this picture on your right is a unit circle, so the radius is 1. So relative to this 30-degree angle, this is the opposite side, this is the adjacent side, this is the hypotenuse. So if we wanted to find sine theta, cosine theta, and tan theta, we can look at those values and we can see sine theta is opposite over hypotenuse, so it is 1/2 over 1, which is just 1/2. Cosine theta is the adjacent over hypotenuse, square root of 3 over 2 over 1, which is just the square root of 3 over 2. Tan theta is just the opposite over the adjacent, so it's 1/2 divided by square root of 3 over 2. If you put that in your calculator, it simplifies to be the square root of 3 over 3. And then the reciprocal functions are quite easy from there. The cosecant of theta is the reciprocal, or 1 over the sine theta, so in this case just 2. The secant of theta is the reciprocal of cosine of theta, which if we were just going to flip them, that's 2 over the square root of 3. In math, we consider it improper, not as pretty, to have a square root on the bottom. So what we do is we multiply top and bottom by square root of 3 over square root of 3. That's called rationalizing. It's just really multiplying by 1 because we're multiplying by the same over the same. It's just equivalent to multiplying by 1, and this simplifies to be 2 square roots of 3 over 3. Similarly, with cotangent of theta, it's the reciprocal of tangent, so 3 over the square root of 3. Again, we have this issue where it's improper to have a square root on the bottom, so we rationalize, or you could just have your calculator simplify it for you, and this becomes 3 square roots of 3 over 3, which is just the square root of 3. Okay, let's look at some more examples, and I do want you to remember from lesson 2.1 that any point on the unit circle, x, y, can also be represented by saying cosine theta and sine theta. So let's use that information to help us solve these questions. Secant pi over 6. If you're more comfortable with degrees, that's similar to asking us, what is the secant of 30 degrees? And for me, I'm more comfortable thinking about sine, cosine, and tangent. So I know that the secant is 1 over the cosine of 30 degrees. Okay, the cosine of 30 degrees is just the x-coordinate at 30 degrees, or at pi over 6. So that's square root of 3 over 2. So we're saying 1 over the square root of 3 over 2, which when you simplify that in your calculator, you get 2 square roots of 3 over 3. Looking at the next point, cosecant of pi over 3. If you're more comfortable with degrees, that's asking us cosecant of 60 degrees. So we're looking here, triangle like that. And cosecant is the reciprocal function of sine, so it's really 1 over the sine of 60 degrees. And the sine of 60 degrees is the y value at 60 degrees. So it's 1 over, again, square root of 3 over 2, which will simplify to 2 square roots of 3 over 3. All right, cotangent of 45 degrees, that's 1 over the tangent of 45 degrees. Okay, the tangent function is the x over y. It's sine over cosine, sine theta over cosine theta. Or you can say cotangent function is cosine theta over sine theta, which in this case is x over y, which in the case of 45 degrees is 1 over the square root of 2 over 1 over the square root of 2, which is just 1. Okay, now let's learn, let's practice what we know about right triangles to solve the right triangles. And that means if you're given 2 sides or 1 angle on one side, we should be able to find everything else. So firstly, they want us to find these trigonometric functions. It's always helpful to find the missing side first. We can do that using the Pythagorean theorem. We'll call this side x. So 7 squared, the leg squared, plus x squared should equal 25 squared. So 49 plus x squared equals 625. So then we'll subtract 49 from both sides, and we'll get x squared equals 576. And then we'll take the square root of both sides, and we'll find out that the missing side x is 24. So now at least we know all 3 sides, so we could quite easily do the sine, which is the opposite over the hypotenuse. Remember, relative to that angle, there's the opposite, there's the adjacent, there's the hypotenuse. So the sine is opposite over hypotenuse, in this case 7 over 25. Cosine is adjacent over hypotenuse, 24 over 25. And tan is the opposite over adjacent, so 7 over 24. Now it turns out that there's a calculator function that once you know the value of sine or cosine or tangent, you can use an inverse function on your calculator to find out what that angle was. So if they're saying sine of some angle theta is 7 over 25, there is a button on our calculator where we can say theta is the inverse, this symbol, of the value 7 over 25. So the angle is the inverse sine of 7 over 25. And you find that button on your calculator by using the shift sign button. And when we press it, we end up getting that theta was 16.26 degrees. Now the only thing we don't know in this triangle is the other angle. Let's call it beta. So remember, the two acute angles in a right triangle are going to add up to 90. They're complementary. So we could find that missing angle by doing 19 minus 16.26, and we'll get that last angle is 73.74 degrees. So we have completed this whole triangle now. Okay, here's another example. It says solve the right triangle. Again, that means find everything. Find every missing angle, every missing side. And they gave us two pieces of information. They gave us that one angle is 32.2 and one side is 6.25. So the first thing I would do is start with what you know, which is 32.2, and label the things you don't know. This is the opposite side relative to 32. This is the adjacent, and this is the hypotenuse. Let's think of a trig ratio that includes something we know, which we know the hypotenuse, we know this angle, and something we don't know. Let's say opposite. So I know that the sine of this angle 32.2 degrees is going to be the opposite over the hypotenuse, right? The opposite over the hypotenuse. In this case, the opposite is b, and the hypotenuse is 6.25. So just to rewrite this, the sine of 32.2, which is just a number in my calculator, equals b times 6.25. If I want to find b, I'll just multiply both the left and the right by 6.25. And this will cancel, and we'll be left with the fact that b equals approximately, there's a lot of decimal places, so I'll take just the first few significant ones, 3.33. So we found that missing side. If we wanted to find the adjacent side, we could do another ratio. We could say the cosine of 32.2 is the adjacent over the hypotenuse, which in this case is a over the hypotenuse, which is 6.25. And again, this is just a number, so I'll multiply 6.25 on both sides. This will cancel, and I will end up getting that a is 6.25 times the cosine of 32.2. And my calculator says 5.2887. I'll round it to two decimal places. 5.29. Okay, now I've figured out both missing sides. The only thing that's still missing is the other angle. That's quite easy because I know that those two angles are complementary. So the missing angle, alpha, is just going to be 90 minus 32.2. And so in this case, alpha is 57.8 degrees. So I completed this triangle. I found everything that was missing. Okay, here's one more example. It tells us that side A is 4.32, side B is 2.62, and we need to compute the angle measures, alpha and beta, to the nearest, that means nearest tenth. Okay, well, there's several ways to do it. Let's start off with alpha. And if we're going to label sides, this is the opposite side, this is the adjacent side. So I can know that the tangent of alpha is opposite over adjacent. Okay, the opposite over adjacent in this case, 4.32 divided by 2.62. So let me just simplify this. Tan of alpha is this expression. Okay, and again, there's an inverse function that we can use on our calculator that says alpha is the inverse tangent, so you're going to press the shift tangent button of this ratio. And after you type it in your calculator, it will give you a value for alpha. And we get alpha is 58.8 degrees. And then there's several ways to find beta. To me, the easiest way is the fact that we know beta and alpha add up to 90. So beta is going to be 90 minus 58.8. So we get that angle beta is 31.2 degrees. If we wanted to complete the triangle and find the missing side length C, we could always use the Pythagorean theorem. We could say that a squared plus b squared equals c squared, and we could put in 4.32 squared plus 2.62 squared is c squared. We end up with c squared is 25.5268, and then you take the square root of both sides to get a final value for c as 5.05. Okay, now we're going to do some application questions. In real life, we have triangles and trigonometry a lot. Why? Because you have tall things, you have the ground, and those situations lead to right triangles. And a couple things we're going to talk about. This name, the angle of depression, is talking about an angle that is going down from the horizontal. An angle of elevation is talking about an angle that is looking up from horizontal. So let's see an example. It says we've got IT students setting up a camera that is 6 feet on the wall, and it needs to cover a horizontal distance of 6 meters, and it needs to cover a horizontal distance of 16 meters. And what's the angle of depression? So we want this angle. And one thing to note is when you have parallel lines, two horizontal lines, and you have another line cutting them, it is the case that this angle and this angle are the same. So they're asking for this angle, but really that's the same as this angle. So relative to this angle here, this is the opposite side. This is the adjacent side. And so we could say the tan of theta is opposite over adjacent, 6 over 16. And again, if we want to solve for theta, we'll do the inverse function. Theta is the inverse tan. We press Shift tan on our calculator of 6 over 16, and we will get 20 point, let's round to 3 decimal places, 556 degrees. Okay, wait, it says 2 decimal places, so we want only 2 of these. Will it stay as 55 or will it go up to 56? It will go up to 56 because this 3rd decimal place is 5 or bigger. So 20.56 degrees. Okay, let's look at this example. There's a drone flight test, and they said the angle of elevation is 30. Remember, angle of elevation always means from the horizontal looking up is 30 degrees when the drone is 100 meters away horizontally. Okay, and we want to know how high is the drone from the ground. So this is some kind of little drone airplane, and we want to know this height y. Okay, so again, relative to 30 degrees, this is the opposite side, and this is the adjacent side. So that the relationship between opposite and adjacent is tan. So tan of 30 degrees is the opposite over the adjacent. In this case, it's y over 100. And I want to solve for y. So I'll multiply both sides by 100, and then I will get the fact that y is 100 times the tan of 30, and I'll plug that in my calculator, and I get y is 57.7 meters, but let me read carefully. It says to the nearest meter, so we'd say it's approximately 58 meters high. Okay, for extra practice, we'll do one last example. We've got some IT students installing a new Wi-Fi router, and they measure at a horizontal distance of 10 meters from the router and find that the signal strength has an angle of elevation of 45 degrees. What's the height of the router at the installation point? So we want to know this height right here. So again, relative to the angle we know, this is the opposite, this is the adjacent. So again, we're dealing with tangent. Tan of 45 is the opposite over the adjacent, which in this case is the y divided by 10. We want to solve for y, so we'll multiply both sides by 10, and it cancels, and we get that y is 10 times the tan of 45, so we'll get that y equals 10 meters high. Okay, hope this helps.